everyone! Today we are going to study one of the most important protective devices in our electrical power system, the lightning arresters. But before we begin, let me ask you this. Have you ever tried nga ni bagyo sa inyong town and then na-sudden kilat? This sudden kilat caused a blackout sa inyong house. Sometimes man good, it's not just a blackout. Our electrical equipment, such as the transformers, the appliances, and the wirings, can be damaged or burned because of the excessive voltage brought by the lightning. So, that's exactly where our topic comes in. The lightning arrestor protects our electrical system against this kind of danger. So, what exactly is a lightning arrestor? Now, a lightning arrestor is a protective device installed in electrical power systems. Its primary job is to prevent damage caused by lightning surges or sudden overvoltages. When an abnormally high voltage arrives at the power line due to a lightning strike or a sudden overvoltage, the lightning arrestor absorbs the excess voltage and diverts it safely to the ground. In this way, our transformers, power lines, and all connected equipment are protected from insulation failure or total breakdown. Now, para mas masabtan ninyo, ang surge or overvoltage, mao ni ang kalit nga pagtaas sa mga voltages nga labaw siya sa normal. For example, ang normal nga voltage sa atong balay is to 20 volts. But when a sudden nga kilat mo arrive, pwede kani nga kilat magdala ni siya og dako kayo nga voltage. So dili kaya sa atong mga appliances ang ingon ana nga kataas nga voltage. Mao ni musulod ang lightning arrestor. Imbis nga kining sobrang voltahe mo adto sa inyong ref or TV, mo intercept siya o mukuha siya sa excess voltage o iyang dalon sa yuta. In this way, ang yuta or ang ground ang mag-absorb sa kaning peligrosong electricity given by the lightning. Now let's look at the parts of a lightning arrestor, where each component plays a critical role. First is the end fitting. These are the metal terminals that connect the arrestor to the power line and to the ground. Next is the wrap. The wrap is a fiberglass layer that holds all the internal components together. Third is the most critical component. These are the metal oxide resistor. It is made of zinc oxide discs, and its job is to absorb and divert surge energy down to the ground. Fourth is the silicone rubber sheds. These are disc-shaped rings that shed water off the surface and prevent surface flashover when an electrical arc forms across the outer surface of the arrestor. Fifth is the insulating bracket, the support structure where the arrestor is mounted while keeping it electrically isolated from other parts. And finally, the disconnector. When the arrestor itself fails, it automatically disconnects from the circuit so it won't cause further damage to the whole system. Now let's talk about the heart of the lightning arrestor, or the metal oxide varistor, or as what we call MOV. So the MOV is made of zinc oxide material. It is the key component that directly protects our electrical equipment from surge voltages. So the MOV works because it's a variable resistor. So meaning an variable resistor, under normal voltages conditions, the MOV has an extremely high resistance. Almost no current passes through it, and everything operates normally. Now, when an overvoltage occurs, when lightning energy enters the line, the MOV's resistance suddenly drops to a very low level. This opens a path for the excess current, which gets directed safely to the ground. Now, para mas masabtan ninyo, kaning MOV is a variable resistance. Mao niya pinaka-astig nga feature. Kaysa normal nga voltage, sure ra kayo siya, dili siya mo-conduct og electricity at all. Taas kayo iyang resistance, so ang kuryente, dili siya moagi sa MOV. Basically, kuan ra siya, standby mode lang siya sa circuit. Murag guard ra bitaw siya nga nagkulat og gubot. Pero once nga naay surge, or kanang voltahe nga mosobra sa iyang limit, dira na siya mo-action. Ang sulod niya, which is the zinc oxide, murag mo-switch ang iyang behavior og kalit. Ang resistance niya, kay mo-drop og grabe. So, moagi dire ang excess current from the lightning og dito siya padulong sa ground or ang yuta nga atong matawag para dili madaot ang uban components, dili siya makalahos sa mga consumers sa mga panimalay. After ana, kung balik na sa normal nga voltage, mo reset ra pod siya. So balik reset siya sa taas nga resistance and ready na pod siya for the next surge. Mao ni ang gitawag nato nga non-linear behavior. Kaya ang resistance niya dili siya fixed, depende ra gid siya kung kusog kayo ang voltage. So, in summary, pag normal ra ang weather, pag walay lightning, taas kayo ang iyang resistance. Now, pag mo-strike ang lightning, pag mo-bagyo, or naay sudden nga overvoltage, dito siya moagi sa ato ang lightning arrestor, padulong sa yuta. Okay, now let's compare two scenarios. One with an arrestor and one without an arrestor. So, in the normal setup, you have a storm cloud outside, so naay bagyo sa gawas. The primary line carries 8,400 volts from the transformer and then is converted to 115 or 120 padulong sa ato ang mga balay. So, na-step down siya. Here in this scenario, without an arrestor, When lightning strikes the power line, the massive surge goes straight into the transformer. Then, the transformer is destroyed. That overvoltage then travels through the secondary line into our home and destroys our appliances. And then blackout happens, or even worse, possible fire. The next scenario is with an arrestor. The moment that there's a surge, the arrestor activates immediately. It diverts the excess voltage to the earth ground. So the transformer is unharmed, wala siya na apektuhan. The secondary line continues to deliver normal 115 to 220 volts to our home, and everybody in there is safe, even the appliances. So, makita gyud nato there ang difference. The difference is really clear, and one small device has a massive impact towards our system gyud. Now, lightning arrestor are found throughout every level of our power system. In the transmission lines, surge arresters are mounted on towers at regular intervals to protect the entire transmission corridor. Next is in the distribution lines. The lines you see on the poles along your street. These are the distribution lines. Smaller arresters are attached near each distribution transformer, directly protecting the unit that serves our neighborhood. Next are the substations. So these are larger. More powerful arresters protect the major transformers and switchgear from external overvoltages before they can enter the distribution network. Next are the buildings, especially tall structure buildings. A lightning rod system uses a vertical metal rod at the top, connected to a grounding wire that safely channels any direct lightning strike down to the earth. Now, there are several types of lightning arresters, which is suited to different applications and voltage levels. So we have rod gap, multiple gap, and horn gap arresters. Now, these gap type arresters use an air gap to break the surge path. When voltage is high enough, it jumps across the gap and is diverted. Next is the spear gap arrestor. It has a similar concept, but uses spherical electrodes for more precise voltage triggering. Next is the metal oxide lightning arrestor. The most widely used today, using the MOV technology we discussed earlier, it is most common in distribution systems. Now, other types include valve type, oxide film, impulse protective gap, electrolytic, expulsion type, styrite, auto valve, and the modern ESE, which is the early streamer emission lightning arrestor used for tall buildings and towers. Now, let's go over the advantages and disadvantages of lightning arresters for a complete picture. In the advantages, it reduces property damage because it significantly lowers the risk of fire and structural damage caused by lightning. It also protects the electrical equipment. It prevents costly damage to transformers, appliances, and the wirings. Also, it enhances human safety. It stops dangerous surges from entering a building's electrical system and harming occupants. And lastly, it prevents electrical magnetic interference, or EMI. It shields sensitive communication and electronic equipment from electromagnetic pulses produced by lightning. Now, on the disadvantages, it requires adequate installation space, especially for the grounding system, which needs proper soil contact. It also has an initial cost, investment required for the device itself, and professional installation. And lastly, it requires regular maintenance, so periodic testing and inspection to ensure it is still functional. To wrap everything up, a lightning arrestor is not just a simple device. It is a critical component of our electrical protection system. With every storm, with every lightning strike, these devices work tirelessly along our lines and transformers, ensuring that electricity remains safe and uninterrupted. Now that we understand how a lightning arrestor works, we can better appreciate the infrastructure that keeps our electrical system and our lives protected. Thank you for listening. I am Bennett Harrison F. Gonzaga, and this is my report for the lightning arresters.